Welcome 10th class students. We'll be discussing this sample test which was based on the topic of light. So let us start with the first question. And this first question, you have been asked that there is a combination of two objects. One is a lens and the other is a mirror. We have to find out what is the power of this combination. Now the simple method for finding power is for any combination is add the individual powers of all the components which are involved. Now in this we are given one concave lens. Focal length of concave lens is 10 centimeters and the focal length of the other lens is 25 centimeters. But you have to be very careful that this lens is convex and this is a concave lens. Now for concave lens, what do? The focal length has to be taken as negative. Now we say that power is sum of the individual powers. In this case this will become P1 plus P2, which should be 1 upon F1 plus 1 upon F2. And we have to express it in meters. So what we will do is power is 1 upon, this is 10 centimeters. If we express it in meters, what will happen? It will be 100 in the numerator with a negative sign plus 1 upon 25. Again this is in centimeters. To convert it into meters, divide by 100. So this comes out to be minus 10 plus 4, which is minus 6 diopters. Therefore, the correct option for first question is B, which is minus 6 diopters. Second question is linked to this first question only, in which we have to find out the focal length of the combination. What we are going to do is, since we have already found out power, we'll use a relation that power is the reciprocal of focal length. So you don't have to solve it again. What we will get is power is 1 upon focal length. Therefore, we already have the power minus 6 equal to 1 by F, or F equal to minus 1 by 6. Now this will be in meters. To find out in centimeters, again you will have to multiply it with 100. So focal length in centimeters will be minus 100 upon 6, which comes out to be 16.66 centimeters. So in this case, option C will be correct. So for second question, C option. Now let us move on to the third question. If the refractive index of diamond for light going from air to diamond is 2.42, what will be the refractive index for light going from diamond to air? The question is very easy. What you have to again remember is, when we find out refractive index, it is the ratio of two refractive indices. Let us say, like in this case, we are talking of diamond as one medium and air as second medium. Now, what they have said is, refractive index if light is traveling from diamond to air. Remember one thing, let us say refractive index of diamond is mu1 and for air is mu2. Here in this question we are not finding the refractive index of one particular medium. We are trying to find out refractive index for a process in which light is traveling from one medium to the other. So we are finding out relative refractive index. Now relative refractive index is always ratio of the two refractive indices. If you can remember that in that ratio, the medium in which light goes afterwards has to be put in numerator. So it will be mu2 by mu1. I am repeating this. Whenever you are going to find out relative refractive index between two media, in that case you are going to find out the ratio of those two refractive indices. Always put the refractive index of the medium in which light is traveling later. If light is going from diamond to air, it is reaching into air, therefore refractive index of air has to be put in the numerator, and from where it started has to be put in the denominator. Doing this, now you will get the answer. For air, refractive index is always 1. For diamond, it has been given to you 2.42. So if you will solve this, you will get the answer is 0.41, which in this case comes out to be the last option, D option. Now, in question number 4, we have been given 3 refractive indices of 3 different media. In this, we have to find out in which light will travel fastest. Now, again we will use the same formula that refractive index is the ratio, but here we will change it a little bit. Refractive index is generally defined as the ratio of speed in air or vacuum to the ratio of speed in the medium. So, since this is a fraction, speed of light is maximum in vacuum or air, therefore the value of this fraction is always more than 1. It is always greater than 1. And if the denominator is small, that means the speed is less, or we say light is traveling slowly, in that case the refractive index will be higher. Therefore, there is inverse proportionality between refractive index and speed of light. So whichever has highest refractive index, in that medium light will travel slowest, and whichever has the least refractive index, in that light will travel fastest. So according to that, our answer will be water, which is A option, because refractive index of water is least of all the 3 liquids. Next question, question number 5. While finding the refractive index of the medium, the speed of light in that medium is compared with speed of light in this. We've just now discussed that when we have to find out refractive index, we compare the speed of light in that medium with the speed of light in vacuum or air. So for question number 5, B option is the correct answer. Let us look at question number 6. The refractive index of 3 media are in order: A is greater than B is greater than C. Light is passed from air into each of these media, in which case there is more bending of light. So they are talking about refraction. When light travels from one medium to any other medium, let us say this is the normal, then it undergoes some refraction, that means it changes its path. Now in this case, since they are asking more bending will be possible in the medium which will be having maximum refractive index, because more the refractive index, more is the deviation from the normal. Therefore, for question number 6, A option should be the correct answer, because A has the highest refractive index. Question number 7. The phenomenon due to which a pool of water appears less deep than it really is. Now, when we are going to look at an object placed in water, let us say this is an object O. The light traveling from this object is going straight out of water. In this case, the angle of incidence is 0, therefore we don't see any deviation. Light is traveling on a straight line. But when there is some angle of incidence which is not 0, in that case light is traveling from denser medium to rarer medium, therefore it will be deviated away from the normal. So it appears to be coming from somewhere over here. As a result, actual depth was this D. Apparent depth is much smaller, because the light appears to be coming from this point. Let us say this is image I of the object O. So it is the phenomenon of refraction which causes a pool to appear less steep as compared to its actual depth. Therefore, for 7th question, B option is the correct answer. Now question number 8. Light appears to travel in a straight line because we all know light is a wave. If the wavelength is very large, then we can see that there is a variation, and the wave does not appear to be traveling in a straight line. But because in case of light we are talking of very small wavelength which is not visible to human eye, that is why light appears to be traveling in a straight line. Had this wavelength been much larger, then we would have been able to see that it is not a straight path, it is a curved path, or it is a variation from a straight line. Therefore, because wavelength of light is small, that is the correct answer. So for 8th question, A option will be correct. Question number 9. A man ran towards mirror with a speed of 5 meters per second. Then the speed of his image with respect to himself will be. Okay. Now try to think of it this way, that we are looking at a mirror. The person is standing somewhere over here, let us say at a distance of 10 meters. His virtual image will be 10 centimeters behind the mirror. So distance between the person and the image is 20 meters. Now if in 1 second he travels 5 meters, which is the speed given to us, this distance decreases to 5 meters and image also comes closer by 5 meters. Therefore, for 1 second in which he has travelled 5 meters, the distance between his position and the position of the image has decreased by 10 meters. So it appears to be coming at a faster speed. That is why for 9th question, C option will be the correct answer. Question number 10. If a glass rod is immersed in a liquid of same refractive index, it will appear. Remember, when light changes medium, if there is a difference of refractive index, then it changes its path, as we discussed right here. But if there is no change of medium, light keeps on traveling in a straight line. Therefore, if an object is immersed into another medium so that the refractive indices of these two match, then we will be unable to see the object because there is no change in the path of light. For 10th question, the answer is it will become invisible. Therefore, D is the correct option. Question number 11. We are given two mirrors inclined to each other. Now this is the kind of questions which you will face in your competitive exams when you go in for IITs or PMTs, because they are going to check your analytical ability in such questions. Now the question is, we have two plane mirrors inclined to each other, let us say at an angle theta. We have to find out the value of theta for which the incident light should always be parallel to the reflected light. Let us try to trace the path. Now, if the angle of incidence is, let us mark it as 1. Light will undergo reflection. It reaches the second mirror. Because angle of incidence is equal to angle of reflection, let us mark this as also angle 1. Now on this mirror, again I am drawing a normal. Let us say this normal is N1, this is N2. Let the angle of incidence be angle 2, then angle of refraction will also be 2. Now our requirement is that these two rays should be parallel to each other. Your first point should be, how can we establish that these two rays are parallel to each other? in case of parallel lines, what do? Draw a transversal. Either we look for corresponding angles, they should be equal to each other, or we look for alternate interior angles, they should be equal to each other. These are two possibilities. Then the third is, if we are talking of two angles on the same side, two interior angles on the same side of the transversal, their sum should be 180 degrees. Out of these three conditions, if anyone is satisfied, we can say they are parallel to each other. Now in this case, if I am talking of these two rays, this is a transversal, then this angle and this angle are interior angles on the same side of the transversal. Their sum should be equal to 180 degrees. If this happens, then we can find out the value of angle theta. Okay, so our requirement is 2 times of angle 1 plus 2 times of angle 2 should be equal to 180 degrees. Now let us look here. This is a normal, this is angle 1. So this angle, what will be its value? Normal is always perpendicular. So this angle will be 90 degrees minus 1. Similarly, this is also normal. So this angle should be 90 degrees minus 2. Here we are getting a triangle. Okay, let me mark this as point A, this is point B, this is point C. Then in triangle A, B, C, what am I getting? 90 degrees minus angle 1 plus theta plus 90 degrees minus angle 2 should be equal to 180 degrees. This 90 plus 90, 180, if we take it on the other side, it will become 0. So what we will get? Theta minus angle 1 minus angle 2 should be equal to 0. Or if I take minus angle 1 and minus angle 2 on the other side, minus on going on the other side becomes plus. So angle 1 plus angle 2 should be equal to theta. Here what are we saying? 2 times of angle 1 plus angle 2 should be 180 degrees. Compare this with this. 2 times of theta will be 180 degrees. Therefore, theta should be 90 degrees. So for 11th question, B option is the correct answer. I am repeating this once. We wanted these two lines to be proved parallel. For that we are using the condition that the sum of angles on the same side of the transversal should have a sum 180 degrees. So this was twice of angle 2, twice of angle 1. So 2 angle 1 plus 2 angle 2 was to be 180 degrees. Take 2 common. Angle 1 plus angle 2 should be equal to 180 degrees. Then we are taking this triangle ABC. In this angle is 90 degrees minus 1. This is theta. Third angle is 90 degree minus angle 2. Sum of the angles of a triangle should be 180 degrees. Take this 90 and this 90 on the other side. This becomes theta minus angle 1 minus angle 2 equal to 0, which means theta equal to angle 1 plus angle 2. Put this value of theta over here. 2 theta is 180 degrees. Theta comes out to be 90 degrees. So B option will be the correct answer for this. Okay, move on to question number 12 now. The focal length of a concave mirror is 50 centimeters, where an object should be placed so that its image is 2 times and inverted. Now, in case of a concave mirror, they are saying that the image has to be inverted. Inverted image means it has to be a real image. Real image is always formed on the same side of the mirror. Let us use the condition for this. They have given magnification 2 because the size of image is coming out to be twice. And the formula for magnification of mirror is minus V by U. From this we get B equal to minus 2 times of U. Let us put this in mirror formula. 1 by f equal to 1 by v plus 1 by u. Focal length is given 50 centimeters equal to 1 upon minus 2u plus 1 upon minus u. So 1 by 50 is equal to, let us take LCM as 2u. So we will have minus 1 minus 2 minus 3 upon 2u. Cross multiply, 2u comes out to be minus 150, u comes out to be minus 75 centimeters. Therefore, for question number 12, A option is the correct answer. Okay, question number 13. A virtual image larger than the object can be obtained by. Okay, we have to obtain virtual image. Now, in case of convex mirrors, the image obtained is virtual, but it is always smaller in size. In this case, what we are looking for is a virtual image which is larger than the object, which is possible only for, which is possible in case of a concave mirror. In case of a concave mirror, if we place an object between focus and pole of the mirror and try to trace the image for a ray traveling parallel to principal axis, it will be reflected back and pass through the focus. And